So the strongest feature of R is its capability to deal with complex statistical operations. I can tell you that R is, if you start working with R, you're gonna love R. If you are using Python before and you start using R, you're gonna love R, seriously. I've used Python, now I'm using R, so I've seen the difference between both of them. I think I love R. You guys are gonna love it. So here we talk about some containers you have in R. Talk about matrices, lists, data frames. You have vectors. I think we've talked about vectors earlier in this class. So first of all, we'll start with matrices. So matrices are data frames containing lists of homogeneous data in a tabular format. So what do I mean by that? It can only contain one type of data. Say if it's numbers, it's going to be numbers all through. If it's going to be characters, it's going to be characters all through. It can only take one at a time. So for performing arithmetic operations on matrices in R, either the elements of the matrices or the whole matrices can be considered as a value to operate on. So if I have a matrix, I can add two matrices together. I can add scalar values to it. I can multiply scalar values by it. But take note that the way you multiply matrices in mathematics is not the way the multiplication works here in R. So let me open my R Studio. Yeah. So it's a two-dimensional array. We have rows and columns. I believe everybody really knows how a matrix looks like. So I can only take one data type at a time, as I've said earlier. So a single dimension vector called temperature, let's say for example, can be converted into a two-dimensional array by using a matrix function. So you can have a vector is just a one-dimensional array, Then you can convert a vector to a matrix using this matrix function. You can see I have a vector called temperature. Then I said, okay, matrix into bracket temperature. Then I put a comma, say n row is equal to 5. This is just going to create a matrix with 5 rows. But it depends on the number of entries you have in the vector that goes to determine the number of columns you're going to have. So let's say it has 15 elements. So if n row is 5, number of columns is going to be 3 because 5 times 3 gives you 15, which is the length of the vector in this case. I don't know whether you understand what I'm talking about, but let me enter R here. So I'm going to open a new script. So let's say I want to create a vector, say temp is a vector of 1 to 15. Yeah, let me call TMP. As you can see, I have 1 to 15. I can convert this to a matrix using the matrix function. So let's say I want to create an object called MATX to be a matrix. I'll say matrix into brackets, then TEMP. I want to convert this vector TEMP to a matrix. So I can say n row is now equals to, if I say n row is equal to 5, let's say n row is equal to 5. So don't forget, by row is false automatically. By row is false, so it means that the way it's going to do the matrix is going, the way it's going to create the matrix is going to be in column wise. It's going to be column wise. So but let me run this first. So let me call my object MATX. As you can see here, you have 3 columns because I said n row is 5, but the length of your vector is 15. So the number of columns is going to be 3 because the size of the matrix is the number of rows times the number of columns. So I have 15. I have 15 elements in the vector, and I want to create a matrix with 5 rows. So definitely I'm going to have 3 columns. So as you can see, it entered the data set in a column form because by default by row is false. So it's going to enter it in column wise. So you can see that 1 to 5 forms the first column, then it continues to the second column to the third column. Now, let's say for example, you want to create a matrix, but the matrix you want to form is not equal to the length of object you have. Let's say for example, this object I have TENP is 15 elements. So if you want to create a matrix that has 5, let's say 5 rows and 5 rows and 4 columns, that's 20 elements. But this object is not up to 20. So what is R going to do in that kind of situation? So let me say matrix TEMP. So I want to create a matrix with number of rows to be let's say, yeah, let's say 5 and number of column. So let's say 4. So you can see you have a warning after creating this guy. You have a warning after creating this guy. So look at it. Because the number of elements I have in TMP vector is 15 elements. But here I want to create a matrix that has 20 elements. Because by the time you multiply the number of rows and number of columns, you have 20. So you have 20, the size of the matrix is 20. So when you go to this place, it doesn't find anything to fill into the last column because I just have 15 elements. Then you now started the entry from the beginning again. You can see you now picked from 1 to 5 to complete the last column, which is column 4. So that's how the matrix is being created. It's going to give you a warning message that what you're trying to do here does not really conform, but you just find a way to complete your operation for you. Okay, so let me maximize this, then minimize. Yeah. So that is one way. So you can also give your matrix a column name and a row name, depending. You can do it from the way from the scratch before you created the matrix, or you can do it after you have created your matrix. As you can see here, so I say columns, call names XY, row names XY. Column names XY is going to give you the column names of that matrix if it existed. And row names XY say, okay, give me, say assign row names of matrix, say XY, to be letters in uppercase. There's a function letters and letters in lowercase, letters in uppercase. This one, it says, okay, give me the first 5 English alphabets in uppercase to be the row names of my matrix. Let's say, for example, this matrix that I've created, MATX. Say I want to give these row names as 1 to 5 here. I want to assign it to, say, A, B to E. So let me type this on my script. Say row names, I'll say row names of MATX, that's the matrix I just created. So MATX. And I'll say it's now equals to letters. So I'll type letters in uppercase. There's a function called it's a vector. Actually, it's not a function. It's a vector that's already been created. So I want to pick the first to the 5 entries. So that will be A to E automatically. So I've run that. So let me call my matrix again, MATX. You can see that the row name has been given A to E. I can do this for I can do the column name. Say I want to give column name XYZ. So call names. Sorry, let me type on my script again. Say call names of MATX is now equals to letters. You can do it. You don't necessarily need to use the vector letters. You can just combine your. What I'm saying in essence is say I can say, okay, C bind capital X, comma, capital Y, comma, capital Z. That's not the way you can give your name manually this way, not necessarily. So I've run that. So I want to call my MATX again. You can see that you have the column names W X Y Z. So let's say you want to just get the names of your rows. You can just say, okay, row names. If I run the names command, there's a names command too. The names function, say names MATX. This is going to give you no. Let me say row names. You can see it gives you the row names, then you can say column names. I have the column names of the matrix, but you use names for data frame, for example. So let's say I want to call a data frame called iris. I've called it. So if I say names of iris, this is going to give you the header, like the header of the name. So you have this guy. You can use it. You can use it matrix. I should be able to use column names with iris data set. So you still give the same result as names. So moving forward. So row and column names can be set and viewed using the row names and column names functions. So I can set it here. I'm calling it to see the column names of XY, but here I'm setting the row names of XY to be the first 5 capital letters of the English alphabet. So here matrices can be used to represent the binding of 2 or more vectors of equal length. So if we have the X and Y coordinates for 5 quadratics, blah, 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 stuff like that. So look at this, for example. You have a vector X, you have a vector Y. I can also form a matrix using the cbind function. I can use the row bind. So cbind is to append it vertically, like side by side on a vertical scale. Yeah. So, but row bind is to append the 2 vectors horizontally, up and down. But column bind is like right to left in dark. So let me show you an instance. So let's say I have X to be 1 to 5, yeah, and I have Y to be so I can say, okay, my XY is cbind. If I say cbind, you see the difference between cbind and don't let me assign it to anything. So I'm just cbind. So you now see, let's say cbind X comma Y. Yeah, you see how it is like column wise, like yeah, column wise. So row bind is row wise. So row bind X comma Y. You can see the way it is now. So that's different. So moving forward, and note if you are c-binding or row binding, it's the 2 vectors has to be of the same length. So let's say, for example, this one is 6 to 9. 6 to 9 is 4 elements. Y15 is 5 elements. So if I say c-bind now, you can see it's actually binded it, but it gave an error because we gave a warning message telling you that they are not. You can see number of rows of the results is not a multiple of vector lengths, blah blah blah. So what is this trying to say? That 2 of them are not of the same length. As you can see here, 6, 7, 8, 9. By the time you go to 9, you can't find the next value to side by side with 5. So you now started from the first number, which is 6 again, so that it can complete the binding. So yeah, the way it is when you are creating a matrix also that does not have that the size does not conform to the length of the vector. Yeah. So okay, moving forward. So we have list. Now list is just how can I say this? So list is a container that can have a vector, it can have a vector, it can have a data frame, it can have a matrix, it can have a matrix in a list. So it's more composite than others. So it can contain any kind of data type at a time. So it's robust, you can use it with anything. You can use the list function to create a list. Yeah, you can use the list function to create a list. So let's say, for example,
Like that data we're working with.
You're talking to the mic. You can hear me.
The data you were working with for that test data.
Which data?
That one for the gun training test.
Okay.
Can we also like do under a list?
Yes, you can.
Because there was something that was going to I saw functions for list, but I realized that one was a data frame. So I did not use it also. So you can actually use it.
Okay. So for example, here I have a vector. So if you want to check type, then is a function type or class. So you want to check the class of a variable. Say for example, if I check class of x now, you see you have integer. If I check for matx, a matrix array. So if I check for iris, for example, you see data frame. So you can check the class of those vectors. So let's say I want to create a list. My list, I'll use the list function to create it. Then I will say, okay, I want x. X is a vector. I want matx. Matx is a what? Is a matrix. I can combine it all. Then I have comma iris. So I just combine a vector, a matrix, and a data frame all together. So let me run this guy. So I have my list. If I call this guy, underscore my list. So you have the whole of this. So you have yeah, this is your list, this is your matrix, this is your vector. So now I can say, you can see that the names he gave to each entry is just by default just give 1, 2, and 3 coordinates. So if I don't want it to have this kind of name, I can say list is, as I can say VEC is equals to this guy, and I can say my matrix to this guy. So this is going to be like the name of the guy. So I will say DF, which stands for data frame, because iris. So if I want this again, I call it. It's going to be the name of those things I've already called it. So as you can see here, you have VEC, which is the vector, my matrix, which is this, and my DF, which is the iris data set. Okay. If we check class of my list, it's going to tell you that it's a list. Yeah. So we are going to go also enter into how to index all these containers, vectors, matrices, and lists as we proceed. Okay. So here they enter the command to create a list called experiments. So site is equal to site. You don't know, site can be a vector. I don't know what it is. Coordinates is equal to paste x plus y separator. There's a paste function you can use to it also works like concatenates also. Temperature is equal to temperature. This temperature is what we created the other time. I think it's a matrix. So you have another vector, say shade, another entry, say shade is equal to shade animation. So list created in above example consists of 4 components. A 2-character vector named site. Okay, this is a vector. A 2-character vector named coordinates. This is a vector of xy coordinates. So there's also a vector, a numeric vector named temperature, and a factor named shade. So data frames. So data frames are just like your spreadsheet kind of data, like your tables. So those are data frames. I showed you what data frame looks like. The iris data set is the data frame. As you can see, you have rows and columns, as you can have in your Excel kind of data. So you can see these are the headers, column names. Then, so a data frame can take different data type, but each column is unique to its data type. So a particular column cannot have different data types as entries. So if one column is numeric, you can't have a character in that same column, but each column can have different kind of data type. So that's about data frame. So mostly data is collected in sets of variables reflecting investigations of patterns between different variables. So consequently, data sets are best organized into matrices of variables, all of the same length, yet not necessarily of the same type. So data frames is used in that case because you have columns that can be of different data types. So data frames are used to store a list of vectors of the same length, yet different types in a rectangular matrix. So all the columns must be of the same length, but they can be of different data type. So, okay. And so which of the following R commands should be used to view the name of the column containing the record of employees? So I think they're using XY. So you use co-names. The third one here doesn't make sense. The first one, this is not how you write it. This fourth one, this is not how you write it. Between the second and the third doesn't make sense because I can't say co-names X in quote command. This doesn't make sense. So you say co-names XY. XY is the variable you are considering in this case. All right. So indexing vectors now. So indexing is a technique to access individual elements and subsets in R. You can call a single element. You can call multiple elements at a time. It can be used to access, extract, and replace parts of an object. So there are 4 forms of vector indexing used to extract a subset of vectors. So vector of positive integers, negative integers, character string or logical value. So we're going to go through how you can do all of this. So we're going to use why this? So we're going to use a vector I've created already. I created a vector x. X is the vector. So let's say I want to have x to be 1 to 5. So if I want to index the second element here, I can just say x into bracket, then 2. This is going to call the second element, which is 2. I can say I want to assign the second element to be 10. I can do this. If I should call x now, you can see that the second element now is now 10 instead of 2. Now, I can call multiple elements at a time. Say I want to call the second to the fourth element. I can do this without stress. 2 to 4. This means 2 to 4. As you can see, I have the second, which is 10, the third, which is 3, the fourth, which is 4. Now, sometimes the way you want to call it might not be in a particular order. So let's say I want to call the first, third, and fourth. You can say I've skipped the second. So the way you can do that is say x in square brackets, then you concatenate the position you want to call. Say 1, 3, 4. This is going to call the first, the third, and the fourth, as you can see on my screen here. Now, you can call based on logical and calling using negative index. So if I say x into minus 2, for example, you can see here, minus 2 is that call x excluding the second index. The second index is 10. So x without the second index is 1, 3, 4, 5. So this is exactly what it's going to do. So putting a negative number in an index is going to exclude that particular element having that index. So I can exclude a couple of elements too. So let's say I want to exclude the second and the fourth element. I can say x then minus combine of second and fourth. So I can exclude the guy in the second and the fourth position in this way. So as you can see here, I just excluded the second, which is 10, and the fourth, which is 4, and it gave me this result. So this is going to, all right, so also say I want to call based on logical value. Say, okay, let's say this vector now, I want to call elements there that are less than 10. So first of all, let me show you this. If I say this less than 10, as you can see here, it gave me true for those index that satisfy this condition. So 1 is less than 10, true. Is 10 less than 10? No, false. All of the rest is also true because they are less than 10. So let's say I want to call the value that satisfies this condition. Then I'm going to put this condition inside x. I'll use the subset x. So I'll say x square bracket. Then put this condition inside this. So this is going to call those elements which satisfy this condition. So it's very, very interesting. Not difficult. Very, very interesting. Yeah. So I think I've covered this. So vector of character strings. Vector of character string. In this case, this guy does not have like a name. Each of the entries does have a name. So let's say, okay, names of xy. You can see you say x. What am I typing? Sorry, not xy. X not. Okay, what if I do something like this? Letters 1 to 5. Letters. So let me call x. You can see x now have name to it. So I can call x based on their names. So if I want to call x based on their name, so I want to call the one with, so I can use in quotes a, comma, say b, comma, say I want to call the one with a, b, and d. So I can do this. You can see 1, 10, and 4. If I just want to call one at a time, I can say, maybe I want to call the one with b, I can do this. So very, very interesting. I think I've covered that part. Yeah. Thank you very much. You want to ask a question? There's no column, there's no, this is a vector. So these are the values. These one are just the, like, a name for all of these values.
Okay, so just assign the name by itself.
I assigned it. You can see this place I assigned names to. So that's where I assign the names. You are not focused on this class. You ask me questions again. Thank you very much. So moving forward. Okay, I've talked about vector of positive integers, how to index. So I've already explained this. So moving forward. Character string. Okay, I've already explained this too. Logical values. Yeah. So this is already covered. Indexing matrices now. So indexing matrices. So so like vectors, matrices can also be the index. So like vectors, matrices can also be the index. So the difference is matrices have 2 dimensions. So we have the columns and we have the rows. So height and width. While vectors have only 1 dimension. So in this case, you have to be able to call them based on their row and column index at the time. So that's the only complexity here. So, but it's not complex. So let's see how we can go about that. Let me open the next tab. Okay. So a vector named salary contains the following elements. So as I've done before, so these are the values and these are the names. So if you execute the greater than salary, sorry, what am I saying? If I execute salary, picking the 3rd to 5th command on this vector, what will be the output? It's going to be Q3, Q4, and Q5. Yeah. And that's the first option, which is the correct option. Before I go to this, let me do an example on how to index in R. Index matrices. So let me call the matrix matrix object I created. Yeah. So let's say I want to index. I want to call the 3rd, the 4th, and the 5th row. Now I want to index the 3rd, the 4th, and the 5th row. Now I want to index the 3rd, 4th, and 5th row. Means I want to call all the columns that correspond to the 3rd, 4th, and 5th rows. Meaning that I want to call 3, 8, 13, 4, 9, 14, 5, 10, 15. So let's see how we're going to go about that. Now, hold on just a minute. So please hold on. Okay. So MATX. So I want to call now. This way you index. So you put a comma here. So to the left of the comma is the index that corresponds to the rows, and to the right of the comma is the index that corresponds to the column. So if you write anything to the left here, it means you are calling the position based on rows. Then anything to your right is called based on columns. So me saying I want to call the 3rd, 4th, and the 5th row corresponding to all the columns. I'll just type 3 to 5. That's 3 column 5. So I want to call row 3, 4, 5. Then corresponding to all the rows. Okay, sorry, I was off for some moment. So let me run this. Did I? What did I do? So please, a minute. So here, I'm calling oh, what happened here? So in the matrix TM, okay, I think when I created this matrix, there was a warning. So here, I'm calling the third. You can see here, I'm calling the whole of this. So and it just give me that. But if I want to call it, say, I just want this to give me go 3 to 5, but for only the second column, say y. I'll just put here 2. So this is going to give me go 3 to 5 based on what the second column. So that's going to give me 8, 9, and 10 as a result. So let me run this. As you can see, 8, 9, 10. Now let's say I want to call it go 3 to 5 based on the second and the third column. Now note that you can also call by their column or row names. You don't need to call by index. Sometimes you might not know the index, maybe it's just the names that you know. So that's also cool. So if I want to call row 3 to 5 based on that correspond to column 2 and column 3, then I have to put 2 to 3 here. That should give you 8, 13, 9, 14, and 10, 15. So for us, you want this, you can see 8, 13, 9, 14, and 10, 15. You can sometimes the way you want to call your rows and your columns might not follow a particular pattern. Then you can use the combine function to do that, to call the particular rows you are trying to call, columns you are trying to call. So let's say I want to call row 1, which is A, row 3, and row 5. You won't be able to use this guy. So what I'll just do is that I'll say combine 1, 3, 5. So this one is saying that I'm calling row 1, 3, 5 corresponding to what? Column 2 and 3. That should give you 6, 11, 8, 13, and 10, 15. So if I should run that, you can see 6, 11, 8, 13, and 10, 15. That's the first, third, and the fifth column. So it's very, very simple. It's absolutely very simple. You can also call based on logical operation. You can call using negative, that is to exclude in that case. So if I put minus here, this is going to exclude the first, third, and the fifth, and give me the second and fourth. As you can see here, the second and fourth is B and D. So you can do that. You can also call based on logical operation. So let's say, for example, say, okay, so let's say for the rows, I can say, let's say I want to call it based on column 1 and 3, for example. So 1 and 3, for example. 1 and 3, yeah. But based on the rows, I want the rows to be based on a particular let's say particular okay, so let me just say this. So let me put this. So I'll do this something like this. So before I write this, so let me call the matrix function, the matrix vector again. So let's say I want to call it based on values that are greater than 5. So let me put this. You can see here, you have So then let me use 5. Let me use 7 instead. So let me call the matrix first. Then let me use 7. And see, all of these are false, 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 but based on this guy. So all we does do is that, okay, I want you to give me this guy, but based on column 1 and 3. So let me run this command now. It didn't give me a result. Say substitute logical, what's it called? It's too long. So because I'm using the old matrix for this logical operation, so I will say, okay, give me check for column 1 and 3 in this case. Yeah. So let's run this guy again. Okay. Okay, let's exclude this part then. Yeah. So you have 6, 7, 8, 9, 10. But if you look at it very well, let me call the matrix again. It gave you this guy 6, 7, 8, 9, 10. Right, and this is not what I want, and that's why I don't want to use that command there. So it's supposed to, I want it to give me the value that satisfy this particular condition. So the way it is going to be is that if give me the rows that correspond to this operation. So the way I want it to return is this guy, this guy, this guy, because this guy is actually false here. So I wanted to bring it correspond to column 2. Oh, I said column 1 and column 3. Column 1 and column 3. Oh, that's why it gave me 6, 7, 8, 9, 10. Okay, I understand now. I understand now. But it's still not, it doesn't still suffice. It doesn't still suffice. The reason being is that 6 is not greater than 7. 7 is not greater than 7. So I'm not supposed to have this to be returned. So, but in a nutshell, you can use logical operators to actually subset your matrix, your data frame, or your vector. First of all, permit me to do this. Yeah, permit me to do this. What am I doing? Sorry, permit me to. Move this. Put this. Put this. Okay, I get what I'm looking for. So, okay, that's it for now. So it takes a lot of practice also to manage all of this at the same time. So you can also use built-in functions. You can also create our own functions. As user-defined functions, they call UDFs. So you have so many inbuilt functions in R. So that is programming in R, because you use functions when you try to create a program to solve a particular problem. So the built-in functions library and add-on tools available for R are extensive and continue to grow at an incredible rate, because you know that R is a public project. Like, it's public, you can download it, it's open source. So you have so many developers working on different functions, and just add it to the package, and it's easily accessible for end users to use it to perform whatever operations they need to perform. So yet occasionally programs require performing a task for which no functions exist. Sometimes you want to perform an operation and maybe you don't have that function. You have to create the function yourself to solve a particular problem. So for example, in SQL now, there is no function. I don't know whether in other SQL language now, there's no function to find median. So you have to create write a script to achieve that, or create a function that's going to achieve that for you. So since R is itself a programming language, extending its functionality to accommodate additional procedures depends on the complexity of the procedure and the level of our proficiency of the user. So it depends on your proficiency for you to create a function that's going to work for you. So that leads us to what we call user-defined functions. In this case, we call user-created functions. So we have expressions, assignments, and arithmetic operations. So moving on to the next slide here. So let's look at expressions, assignments, and arithmetic operations. So this arithmetic operation, this plus this minus this divided by this, and stuff like that. Assignments operation, okay, I'm assigning 2 plus 3 to a particular variable. So I can use it maybe later on in my maybe analysis. So we can also perform operations with variables. So I created a variable called, okay, not yet. So when the content of the vector are numerics, standard arithmetic operation can be applied to it. So let's say I have a variable called var2. I want to subtract 1 from that variable. I can say var minus 1. Since var2 is a numeric vector, I can subtract 1 from it. But if it is not, it's going to throw up an error. This is the normal division operation. So what are we saying in essence? So, before that, you can also write a lot of operations on a single line. So you can use the semicolon to end each operation, use a semicolon as a delimiter in SQL. So you can use it in R. So this one is saying that, okay, A is 1. I want to assign 1 to A. Then this one has ended here. I'm to assign B to 2 to B, assign A plus B to C. So for instance, okay, first of all, let me start from here. I created a C, so C 5 or 4. So I do C divided by 2. This is going to mean 2 because I has already identified C to be 4, so I can do C divided by 2. So if I say C, let's say C plus LO now. This does not make sense. Or C plus LO. This might throw up an error because you have a numeric variable and a character variable at the same time. So it's an error. So C plus LO, non-numeric arguments to binary operators. So this wouldn't work out. But okay, so let's look at the grouped expression. So I want to say C equals to 10 now, and say D equals to 5. I want to say, okay, E equals to C divided by, C divided by D. So I'll set entities, yeah. So let me run this line. So if I should call E now, you can see E is 2, that is 10 divided by 5. So I just ran a single, multiple commands on a single line using that colon as a separator. Yeah. So let me quickly move on to the next slide because I have limited time to finish up this because I think I have power. I have power in Jesus' name. So conditional execution. So if and if else statements now. If and if else statements. So they are conditional statements. Now you can have, okay, if a particular condition is true, I want you to do this. Then you have the if else. So if else is that if this condition is true, do this. Else, do this. Now else does not need a conditional state. It doesn't need a conditional expression or a condition. So what I'm saying is that, okay, for example, I want to send someone a message. Okay, take this 1,000 naira. Go to the canteen. If there is amala, buy so. Else, buy this. Now, else, you can say if there is amala, if there's the condition is if amala exists, buy so. But else means that if that condition I gave you does not hold, do this. So there's no condition that is attached to else. Else is like after everything has failed, do this. Then you have if else function, which you can use to append the if else statement on a single line. So let's see how that works out. Okay, they didn't talk about this. So let me just put us through on the R console. So if, let's say, if condition through the tags, if condition through the tags, else this, you can do this, and you can use the if else statement at the same time. So let's say, for example, if okay, now you can say C is 4. So I'll say if C is less than 10, let's say print hello world. Oh, sorry, and this guy here, and this guy here. So yeah. Okay, let me say return. Let me use return keywords and return